The first thing that I want you to go to tell me is the square root of 48. Now, you're not going to be able to put that in your calculator and tell me the answer. I do not want to know 6 point blah, 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 blah. Okay? Because that's not reduced. I want it simplified. Okay? So for something like this, I want you to simplify the square root of 48. Okay? I'll give you 45 seconds in your group.
2 square root 12.
Oh no.
I haven't done this in forever.
I don't know what to do.
I get to use
How do you
this
square
thing.
root something?
See, that's what we don't want. We got to reduce it.
Oh, yeah. It's 2 times the square root of 12, isn't it?
Okay? That's what you guys got?
That's gotta be it.
How'd you guys get? 2 square 12? Okay.
Thank you for
What'd you guys get?
6 square root of 2.
6 the square root of 2. Patience, you got, here, let me write all the ones on there. We got 2 the square root of 12, that was out of 2 groups. 6 the square root of 2, that was one group. 4 the square root of 3 was another group.
What the heck?
2 root 6. 2 root 12, okay. There is a right answer, and it is up there.
That's what I got.
One of those answers is right, the other 3 are wrong. Okay, so, all right, this is what all of you guys wrote. This is, I just went around to each group, and a couple of you guys had 2 root 12 and whatnot like that. One group is correct up here. Patience, how'd you do it?
So the first one was 2 square root 12, but that can be simplified into 4 square root 3. So like, yeah.
So the 2 root 12 was not far off. It actually was close, but the 12 could go further. Now when you were growing up and doing this, here's how your teachers went through how to do this. You had 1 squared is 1, 2 squared is 4, 3 squared is 9er, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, that's too high. Then what you were asked to do was those numbers, 1, 4, 9, 16, 25, 36, blah, what numbers multiply together to give you 48? 1 times 48, 4 times 12, which is what some of you guys were thinking of, 9 times nothing, 16 times 3, 25 times nothing, 36 times nothing, 39 or 49 is too high. The lowest one on this one is the group that you'd use. So then you were taught, well, the square root of 16 times 3, and then you went like this, the square root of 16 times the square root of 3, and then what's the square root of 16? 4. Okay? Most teachers teach you how to do square root like this. Does that seem to ring a bell?
Yeah.
Okay, all right. Now, can I show you an alternative?
Yeah.
This right here works great, but what happens if I give you a number like, I don't know, 3,840? It might take a while to do that. So, I'm going to do the same problem, and I'm going to show you how I do them. I used to do them like the way you guys did too. The first teachers that I had that showed me square root, that's how I did them also. It wasn't until I was in Algebra 2 in high school where my teacher showed me a different way, and I don't do it the other way anymore. So what I'm going to do is, I'm going to ask you guys a question. When you guys were multiplying when you were in elementary school, did you ever have to do factor trees?
Yes.
Yes, you do. Or you did, right? And some of you remember how to do it, some of you don't. Now imagine taking the number 3,840 and trying to do a factor tree for that. Would you want to?
No.
No, and I don't either. I don't even want to do it for 48. Because when I did 48, when I was growing up, this is what would happen. A lot of times I would have like 16 and 3, and then this is 4 and 4, and that's 2 and 2 and 2. And guess what number would I leave out?
3.
Right. So when I did factor trees, I'd miss a number, and if you miss a number, that's not good. So in order to organize my data, I call it a factor T. Now, instead of a tree, I'm going to put it in a T format. The first prime number that we have that goes into 48 is the number 2. 2 is the first prime number. 2. What's 48 divided by 2? I put the 24 underneath the 48 and I start over. Does 2 go into 48? How many times?
Oh,
12.
I thought you said 48. My bad.
He did say 48.
Come on, you got 2 there.
Huh? Yeah. Yeah. Does 2 go into 12? How many times? Does 2 go into 6?
3.
And does 2 go into 3? No. The next prime number is the number 3. Does 3 go into 3? Yeah. How many times?
1.
Once. As soon as you get a 1 on the left-hand side, all those numbers are dead to me. So I'm just going to cross them out. Oops, sorry, channel my inner Canadian. Now, square root, and the reason why we're saying it and I'm overemphasizing the square root on that, square means how many? 2's, right? Square is 2, square root is undoing 2's. So what I want you to do with the list that we have up there on the left-hand side, is there a pair of the same number?
2.
Yes, there is one pair of deuces.
There's another pair.
There's another pair of deuces.
And then there's an odd Todd.
And then there's an odd duck. That number 3 does not have any friends. So it does not get to go outside. What I mean by outside is, the square root to me is like a house, like you're putting a roof over the house. So the number that did not get included, the number like the number 3 is not having any fun. That stays inside the house. If there were more numbers that did not get circled, I would multiply them and keep them underneath the house. Now, what goes on the outside? What number did you circle here?
2.
A 2. What number did you circle here? A 2. That 2 2's gets to go outside to play. And when they go outside, they multiply with each other. What's 2 times 2? 4. And that's how I do these. I did not have to figure out all the perfect squares to how many ever numbers that I had to do. I used to have somebody in a colleague of mine that had their students go all the way out to 30 squared. That's okay. I agree with you. Because if I did that number, 30 squared is not high enough. 30 squared is 900, and that doesn't nearly reach that number. Yes, Deb?
What's the name of the unit?
It's just mathematical proficiency. This is not a unit yet. It's just reviewing some steps for you guys. So, if I tried to do it the old way, do you want me to do it the old way?
No.
I don't either. So 3840 goes inside the T. Now start with the number 2. Does 2 go into 3840? Yeah. How'd you know? Good. What do you get? 19 what? 20? Does 2 go into 1920? Yeah. How much? 960. Does 2 go into 960?
Yes.
Yeah, how much?
480.
Does 2 go into 480?
240. 20. 60. 30. 15.
Does 2 go in there? Yep. Does 2 go in there? Does 2 go in there? This 2 go in there? All right, now. I know we went through that kind of quickly, but you know what? Have I really had to think? No. I have not had to think too much. I'm still not done with the number, but I ran out of room. But I didn't have to think, because realistically all I could have done was type the number 3840 on my calculator and just hit divide by 2. Divide by 2. And then the calculator is doing it all for me. Now, does 2 go into 15? No. The next prime number is?
3.
Does 3 go into 15? Yes. How many times? 5 times. Then, does 3 go into 5?
No.
Does 5?
Yeah.
And then there's a 1, so now all the numbers on the right side are now dead. Now I'm going to go back and circle pairs of the same number. 1 pair of 2s, 2 pairs of 2s, 3 pair of 2s, 4 pair of 2s. Any other pairs?
No.
No. The 3 and the 5 cannot be circled even though there are 2 numbers, but they're not the same. So on the inside, what's 3 times 5? 15. Awesome. Now, when you do the outside pieces, 2 times 2 times 2 times 2. That 3840 really reduces down to 16 root 15. Did we have to think overly too much about how to do that problem? I hope not. What do you think of this method? Now, the reason why I showed it to you is for not just because of this, but also here in a couple more chapters, I might put a 3 in the crack of the foundation of your house. Then instead of square root, that says cube root, which means I look for groups of 3 of the same number. Or if I put a 4 in the crack, then I look for 4 of the same number. Or 5 in the crack, 5 of the same number, and so on. Now again, remember my friend I told you about that used to have their students do all the way to 30 squared? They also made them do 30 cubed and 30 to the 4th. And have this on a piece of paper somewhere. Now, why should you have to do it when you can just do it this way?
No reason for it at all.
Okay?
How did you get 15?
How did I get 15? You had a 3 that did not get circled, and you had a 5 that did not get circled. And so, Jay, 3 times 5 is 15. Okay? Now, you might also have a fraction. What?
Is there ever a chance that you could have 3 numbers that are circled?
Yes.
Then would you just multiply all of them?
Yes.
Oh, okay.
Or you could have 4, or... Okay, what happens if you have a fraction? Does anybody know what to do with fractions?
No.
You separate them into top versus bottom. Square root of 3, square root of 4. Does the square root of 3 reduce? No. Does the square root of 4?
Yes.
Yeah. What's the square root of 4? And then as long as my number on the bottom does not have a square root, I'm good. So this problem is donezo. Now, what happens though if I were to say 5/8? When I split them, like we just did, the square root of 5 over the square root of 8. Does the square root of 8 come out evenly? No. It's 2 point blah, 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 blah. So when it does not come out evenly, in order to get rid of it on the bottom, you need to multiply it by itself. So if I multiply something in a fraction by itself on the bottom, what you do on the bottom, you must do on top. What's 5 times 8?
40.
So on the top, I got the square root of 40. On the bottom, what's the square root of 8 times the square root of 8? It's 8. And how I got 8 was, or Kristen, how did you get 8?
8 times 8 is 64. The square root of 64 is 8.
Awesome. I don't know if anybody heard what Kristen said, but she said the square root of 8 times the square root of 8 is 64, and the square root of 64 is 8. Okay, that was correct. Now, I need to reduce the top if I can. So 40 is going in my T. Does 2 go into 40? Yep, how many times? 20. Does 2 go into 20? How many times? Does 2 go into 10? 5 times. Does 2 go into 5? Does 3? Does 5? I got 1 pair of deuces. Any other pairs of the same? No. What goes on the outside? No. Outside? No. 2. What number did you circle? You circled the 2. What number stays on the inside? 10. This 2 times 5 is 10. Those 2 losers have to stay inside. Now, with this, when it says 2 root 10 over 8, the 10 is safe. You cannot touch the 10 anymore. You've already reduced it as much as you can. The 10 is in the safe zone. No touchy. So, you've got a 2 and an 8 on the outside, though. What number goes into both of them? So, if I divide them both by 2, I have the square root of 10 over 4. Nice. That's half of your assignment today. Just doing that. Okay? The other half of your assignment looks like this. X squared minus 16. And it's going to say factor.
Oh my god.
I know you love doing this. Okay? So, how do I factor?
This one's tough. I can't remember it. It's not tough.
Okay, one thing with this. When you're doing problems like this when it says factor, is there an equal sign in this problem at all?
No.
No. Do not make one. Okay, a lot of people do that. They put it equal to the 0 and they try to solve for x. It never said solve. It just says factor. So when you factor, here's what you should look for. First thing you should ask yourself is, self, is there anything I can take out of both terms?
No.
Because one's got x squared and one's got a 16. There's no common ground there. So no. Then the second thing that you need to do is maybe write 2 sets of parentheses. And then you go, what times what gives you x squared?
X times X. Welcome.
And then what times what gives you 16, or excuse me, negative 16,
4 times negative 4.
when, and if you then add them, gives you 0.
Can you run that back, please?
4 and negative 4. You're too busy answering the question instead of just listening.
But I got it right.
You want to ask yourself, Devin, what times what gives you negative 16 but adds up to be 0? 4 and negative 4.
Oh, I got it right.
And you're done. There's nothing else to do with this problem. Okay? You're not solving. It does not say solve, it just says factor. Okay? X squared plus 6x plus 9er. Is there anything you can take out to begin with? I cannot do an x because the 9 does not have an x attached to it.
True.
How about a number? Can I take out a number?
Yeah.
No. Because there's no 3 in the front.
No, like 6, 7, 3, 9.
But I'd have to do it for all of them, Jay, not just one piece or...
Oh, okay. Then no.
Okay? Huh?
Take out the square.
No, not yet. Nope. Okay, and what a lot of people try to do is they try to square root things. We're not doing that here, it's factoring. So, ask yourself, self, what times what gives you x squared? X times x. What times what gives you 9 but adds up to be 6? And
0. No, that doesn't work.
9 times 0 would not be 9. Okay, be careful, Jay. So 3 times 3, right? Now, if you're not sure, Check it. What's 3 times x?
3x.
And what's 3 times x again?
3x.
And when you add 3x plus 3x, what do you get?
6.
And is that the middle one? Yay, so that means we should be smiling and happy. Okay?
Did you say that the factors could equal 0?
On the first one, because there was nothing in the middle.
Yeah.
Now there's something in the middle.
So you want it to equal the last one.
You want it to equal what's in the middle. When you add them, they should equal what's in the middle. So we always ask Jay, what times what gives you 9, which is 1 times 9, or 3 times 3? Which one of those pairs is going to add together to make 6?
Okay.
Okay? Now, one of the other things that you also can do with this, do you notice it's the same group twice?
Yeah.
Another way that you can also write this, and this isn't today, I'll take either way, but just so that you guys know, in future, that's how we're going to probably write that answer. X plus 3, the quantity squared, is the same as x plus 3 times x plus 3. Whichever way you want to write that answer, that's your choice. Okay? Have you done this before? Yes. So just to kind of review with you. All right. So on page 91, 1 through 14.